Today we're going to be taking a quick look at a few examples very similar to the quadratic and sine wave transformation assignment to kind of give you a guideline on how it should be done and just to kind of go over some examples. So in the first one, we're given a quadratic function here, and we want to be able to draw in the actual transformation. So there's different ways you can do it. You could start off by drawing the base form of the transformation or of a quadratic, which is y equals x squared. And if you go back to the notes, we should see that this is what kind of the base form looks like. So that is our base form. Again, you don't need to draw this, but if it helps you to do it this way, you're more than welcome to. So if I want to jump right into just drawing what the transformation is, I can use my knowledge of the vertex form and our transformations. So if I look at my value here, the -3, that actually means that I'm moving to the right 3 units. And if I look at this value here, that means I'm moving down 1 unit. And that is all I have. Those are my only transformations. I don't see a value in front other than 1, which means that it doesn't change. So that step pattern will stay the same as 1, 3, 5. Remember, if we think back to 1a, 3a, 5a, if the a value is 1, right? So remember the general pattern was 1a, 3a, 5a. So if my a value is 1, 1 times 1 is 1, 3 times 1 is 3, 5 times 1 is 5. So that's my step pattern doesn't change. The vertex I am getting from, again, the h and k value. So this means that my vertex is 3, 1, -1. Again, opposite of what we see in the bracket, and just that last value. So I can do one of two things. I can use this transformation and transfer all these points or apply these transformations to these points, or I can draw in my vertex and use my step pattern. Either way, I should get the same answer. So let's just start with drawing the vertex, because this is an easy way to do the transformations without really knowing what they are. If I know my vertex is over +3 and -1, and I know my step pattern is over 1, up 1, over 1, up 3, and I can't really do 5 on the next one, and I know that it repeats on the other side. I can draw in my graph. So there is y equals x minus 3 squared minus 1. So that's the transformation. So that's my transformed function, or the function y equals x minus 3 squared minus 1. I'm going to erase this and show you how you can do the other way as well and still get the same answer. So I know my transformation is that it's right 3 units and down 1 unit. So I have some key points already identified, these dots here, and I'm going to use these to apply the transformation. I'm going to start at my vertex, and I know this vertex has to be moved 3 units to the right and 1 unit down. So I'm going to move it 3 over and down 1, and that's where my vertex is now going to be. I'm going to do the same thing with this next point. Move it over 3 and go down 1. That's the transformation. There's my next point. Same thing with this top one. I'm going to move over 3, down 1. There's my transformation of that point. So kind of like a drawing exercise of following directions or just transforming. And I can do the same thing with the other points. Over 3, down 1. Over 3, down 1. And there is my transformed graph, which is the exact same thing as what we had just done. Just a different way of doing it. So again, either way you choose to do it is up to you. I always, again, highly recommend drawing the base form because it does help us show or understand how the transformation actually occurred. And using two different colors definitely helps, but if you don't have that ability, that's fine as well. So I'm not going to do these ones because they are the same as the homework, but I can go and do another couple examples here. So let's try this one. Y equals 3, x plus 3 squared minus 6. Again, I'm going to start off with the easy way of what are our transformations. Well, if I look at this value here, that plus 3 actually means I'm moving to the left 3. I have this negative 6, which means down 6. I have an a value of 3, so that means a vertical stretch by 3. So that means my step pattern, if it's not 1a, 3a, 5a, a value is actually 3. So 1 times 3 is 3, 3 times 3 is 9, 5 times 3 is 15. So that's what my step pattern is. And my vertex is actually going to be -3, or the opposite, and -6. So this one's going to be a little bit trickier because we do have this stretch or vertical stretch in play. Again, I'm going to draw in my base form to help me with my transformations. So there's my base form, y equals x squared, and now I'm going to apply my transformations. So again, you can do it one of two ways. You can plot your vertex, so at -3 and -6, and then use your step pattern over 1 up 3, over 1 up 9, and draw it in there. And that would give you your new function, or your function, the y equals 3x plus 3 squared minus 6. The other way you could do it, and I'll again go the other way as well, apply the transformation to each one. So the way this works, because we have that vertical stretch, if I start at 0, I know I have to move left 3. I have to move down 6, and I need to apply a vertical stretch of 3. So it's actually helpful to do the vertical stretch first, because if you apply the vertical stretch after, it can get a little confusing. So if I apply the vertical stretch first, my y value here, remember this is the point 0, 0, if I apply the vertical stretch, or if I multiply this y value by 3, 0 times 3 is 0, so it doesn't really affect it. So now I applied my vertical stretch, it doesn't change it. Now I can move it to the left 3 and down 6. If I look at this point here, 1, 1, and apply my vertical stretch to the 3, or to the y value, because again it's vertical, 1 times 3 is 3, so this value automatically jumps up to here, and now I have to move it over. Let me actually use a different color. Use black. So when I apply the vertical, or I'll use yellow or orange. So when I apply the vertical stretch, it jumps up to here because I multiplied this y value by 3, but now I have to move it over 3 and down 6. This gets me to here. The other value makes it tough to do, so that makes it difficult because I would have to go off the graph. But again, I could do the same thing. This value, or this point in my base graph, has a value of 2 and 4. Actually, I can't do this one. If I apply the vertical stretch to it, take that 4 and multiply it by 3, it puts it off the graph. But when I would come back and draw it, I would get it and moved it, it would end up being here. So sometimes it's easier just to understand what the step pattern is and know how to draw it starting from the vertex. So if you can apply where your vertex is, then use your step pattern for the over, in this case, over 1 up 3, over 1 up 9, over 1 up 15. It makes it easier to draw in the transformation. We'll do one more example, and then we'll look at a sine wave example. So here, y equals negative 0.5 x squared. So this one is a little bit straightforward. The transformations that we're actually looking at, there's nothing in the bracket, or there is no bracket with the x, so there's no left or right transformation. There's nothing added or subtracted after, so there's no up or down or vertical translation. There is a number in front though. So because it is a number between 0 and 1, that means we have a vertical compression by a factor of 0.5, and because it's negative, it is flipped. Our step pattern, again going from 1a, 3a, 5a, actually gives us 1 times negative 0.5 is negative 0.5. 3 times negative 0.5 is negative 1.5, and negative 2.5. Let me just move these apart. And our vertex, because our vertex hasn't changed, or there's no up or down transformation, our vertex is still 0, 0. So that makes it a little bit easier to draw. So we know, starting with our base graph, it will look something like this. Again, that's our base form, y equals x squared. That's what we're always referring to, or the transformations always start from this one. Now, because it is vertically compressed and flipped, we could just start right from this graph. We know the vertex is going to be the same. We know what the step pattern is. It's over 1, down 0.5, over 1, down 1.5, over 1, down 2.5. And it's going to be repeated on the other side because, again, it is symmetrical. Again, you could apply the same transformation by saying, okay, what is the vertical transformation? So at 0.5, if it gets compressed, or at 1, sorry, it gets compressed by 0.5, that means it actually goes here. So each one of these gets dropped by half. And then what happens is we flip it. So that means if we treat kind of this x-axis as my mirror, all of these points get transferred to the same spot, just on the other side. Except obviously for the vertex, which doesn't move, because it's still 0, 0. So this is y equals negative 0.5 x squared. So I would say the hardest part is looking at the, or is applying the vertical stretch and compression. The left and right, up and down is the easiest, but if you use that to at least figure out the vertex and understand how the new step pattern looks based on the stretch or compression by using the a value, then it's easy to figure out where your other points are.